Hello, everyone. I hope people can sort of see me and hear me. This is my very first live stream, so I'm super excited. I have no idea if people can hear me / see me. Hello. Let's just double check. Yes, fantastic. Fantastic. Welcome, everyone. I'm very, very excited to be chatting with everyone. Hello, Fiverr. Hi, Jack. Hi, Natalie. Hi, Dee. Hi, Mia. Hi, Damage. Hi, Oil. Hi, Jules. Hi, Ariane. How's everyone doing today? Oh, you can't. Patrick, can you not see me / hear me? I think everyone else can, so I'm not 100% sure. Okay, amazing. Fantastic. Really, really good. Okay, so my internet is a little bit slow, so my apologies if if it slows down at some point, but just please bear with me. Right, let's jump. Yeah, you will be able to watch this straight afterwards, Claudio. Yeah, I do have some Edexcel questions in the live stream. So, what's the main point of today? The main reason why I'm live streaming is because I want to give you some actual real feedback on your work. I'm going to be going through a series of describe, explain, discuss questions. And over 1 hour, maybe a little bit more, on a kind of a first come, first serve basis, I'm going to be trying to give you as much live feedback, either sort of verbally or via the chat as well. So, right, let me see if I can figure out how to actually share my screen. Okay, so 1 second. There we go. Oh, really? Yeah. Well, my internet is actually just a hotspot from my phone, actually. So I'm very pleased that this happens. Okay, now the first thing, something should have appeared here. Okay, yeah, perfect. So what I want you guys to do is, can you rate your revision out of 10? Let's rate our revision out of 10, everyone. Okay, got some nice normal distribution curve over there. Okay, people tend to kind of shy away from kind of rating the revision as a 10 out of 10. But I'm sure that there's some solid 9s and 10s. 7 just past papers. Okay, yeah, cool, excellent. Now, what we're going to be doing today is we're going to be looking at command words. So how do I make this full screen? Honestly, I should know all this. I can probably get away with being full screen. There we go. Okay, so we're going to be looking at some of the command words. So if we ever come across the command word which is state, that simply means tell me a value, tell me a fact, tell me a physical principle, tell me a law. If it's a mathematical question where you have to state a value, very often consider values such as the weight, consider 0. That's very often, so the resultant force might be 0. Okay, if we have a command word which is describe, well, tell me what you see, tell me what the data shows, tell me what potentially will happen. Explain, and this is a really important one, is tell me why. Discuss and suggest, they're very, very similar to explain, but they're a way to provide a little bit of freedom. So what it really means is use the laws of physics to discuss what will happen, and you choose which laws are relevant to that situation, and then you apply them. Little subnote here that usually we have equations that are actually involved over there. Okay, so let's start off with a simple one, and I want every single person to get involved in the chat. So here's a little question. I think this one is from OCR, but once again, I've chosen questions so they're completely relevant to everyone. Okay, what do we have? We've got an archer fires an arrow towards a target as shown at 11 degrees. Describe how the kinetic energy of the arrow changes during its journey from when it's fired, somewhere over here, well, I don't have a mouse, never mind, until it reaches its maximum kinetic energy. Do I have a mouse? I don't know. Okay, describe how the kinetic energy varies. Okay, let's have a go in the chat, everyone. Oh, you can't see. Oh, sorry, my bad. What about now? Yeah, sorry guys. I think when I went to full screen, it basically just got rid of the question. Apologies. Thank you very much, chat. I think I'm enjoying streaming. I should do this more often. Good. Okay, so it's a 2 marker. I want to see 2 specific points, Sergio. Okay, 2 specific points, please. 2 specific points. So kinetic energy starts at 0. Okay, so cash stack, the kinetic energy we always tend to consider projectile motion for the moment they're actually fired. So, and is maximum when maximum height is reached. So it's actually the opposite. So it starts off at a certain amount of kinetic energy, but then you have to think about what happens to the vertical component. Because in projectile motion, see if I can draw over here. Hopefully you guys can see this quite clearly. I was going to connect my iPad and do all these complicated, I don't know, technology bits, but you know, good old whiteboard actually works. So we're going to have some velocity over here. So what we need to comment is what happens to the vertical component, I'm just going to call this Vy, and what happens to the horizontal component. So this component Vy will end up getting smaller and smaller and smaller. So if I was to just draw the Vy component, it's going to be smaller and smaller, and then it will eventually be 0 right at the horizontal bit. Okay, good. So, right, let me go back to this. So, maximum kinetic energy at the start. Oh, hi, Lewis. Thank you very much. You've inspired me to live stream. Fantastic. Okay, so let's do a bit of marking. So, okay. Minimum of the maximum height. Jules, this is 1 out of 2, not 0. So Jules, what you need to say is that in that first instance that the kinetic energy will end up decreasing from the start all the way to the maximum height. That will be your first mark. Ashley, the kinetic energy will decrease as it goes up and reaches a minimum with a vertical velocity being 0 at maximum height. Okay, so Ashley, this is really, really interesting. So your physics is absolutely correct, but what you want to do is to answer the question directly. So because the question is asking you about the kinetic energy, what you want to do is, well, talk about the kinetic energy rather than just the vertical component, which is the explanation bit. So this here is the subtle difference between a describe and explain question. Okay, Angie, decreases from launch as kinetic energy is transferred to gravitational potential energy. At the top, kinetic energy is 0. Okay, so Angie, the kinetic energy at the top will not be equal to 0. The kinetic energy at the top will be at a minimum because it is still moving horizontally. So that horizontal component is still kind of like there somewhere, and that remains sort of constant across here that are okay, so for kinetic energy isn't 0 at the top because it has horizontal velocity. That's fine, but what you want to do is to describe how the kinetic energy changes. Okay, Mia, the kinetic energy decrease to reach maximum height. Perfect. Okay, now what you want to say is that the kinetic energy at maximum height is kind of non-zero. It still has to be there. So maybe I would give that a 1 out of 2. Okay, movies. Initially, it has kinetic energy EK, then it's slowly converted to GPE until the max height where GP is max and EK is 0. So at maximum height, it still has some motion. It's still moving horizontally. Shall I demonstrate this? So imagine the pen is that projectile. So here we start off with like this, and then right at maximum height, it is moving with with some amount of kinetic energy. Okay, right. Ren. Oh, hang on. Okay, I can't scroll. Highest kinetic energy is initially when vertical velocity is 0. Yeah, very good. I love the mention that that you've split this into the vertical velocity, so it's still certain value. Ren, this will almost certainly will be 2 out of 2. Just a little disclaimer that I'm not an examiner at the moment, but I'll do my best to mark all of these as accurate as possible. So Nick Warrior, it is a minimum at the top of the journey, maximum height, then kinetic energy is maximum at the lowest point. Yeah, perfect. You've described this really well. Natalie, K is highest initially as it gets to the top, then it gets to the bottom, and then kinetic energy increases and GP decreases. Okay, so you definitely want to mention the fact that it's a minimum right at the top. Okay, kinetic energy increases as GP increases. So the start of the journey, okay, EK is max. Okay, so right, let's have a look at the actual mark scheme, because a lot of the comments tend to have pretty similar ways to answering them. Now, look how simple, hopefully you guys can see this, but just notice how simple the mass schemes tend to be. So kinetic energy reduces with height, and then at maximum height, kinetic energy is a minimum / non-zero. If we had to express it, by the way, it'd just be a half mv cosine of 11. And probably a question will go on to calculate this if I remember it correctly. Okay, now, what I want to ask you guys is, this will be applicable to all exam boards, but I imagine that there's a substantial number of you doing AQA. If you're doing AQA, could you make yourself known in the chat, please? Would you say it's a minimum at 45 meters? Yeah, absolutely. Yeah. Yeah, don't worry, this was an OCR question, and what I'm about to say is very applicable to AQA as well. Just that for you guys, it will be just for paper 2 if you're doing OCR, but it will only be for around 15 minutes, then I'll go back to OCR, and I'll be doing OCR 6 markers afterwards as well. Edexcel, yeah, I've got some Edexcel questions. I've got a really good Edexcel question as well. I'm filming a different one for Excel as well. Okay, amazing, excellent mix of people. Fantastic. So I've got 2 6 markers prepared, so hopefully I will do my best to try and demystify them as much as possible. Now, I wanted to share something which is really, really interesting, but I mean, very often in A-level physics, you get this a sort of structure. So I've made something which is pretty sort of similar to an A-level physics question. If you're doing AQA, this will be very relevant to your paper 1. If you're doing Edexcel and OCR, the content will be more relevant to paper 2, but the way to tackle the questions is exactly the same. Now, you may have something like a complicated looking diagram. There's a particular reason why I wanted to just write complicated looking diagram then give you something like this, because very often they might give you a really, really complicated looking question, but then the first little bit might be totally, totally fine. So it may not even be related to what the diagram is happening. By not related, I mean you can answer it without even looking at this diagram. So this might have been a diagram of a complicated diffraction gradient. I've got a diffraction gradient somewhere here, never mind. But what I want you guys to do is we're going to follow a little structure, especially if you're doing AQA. On Friday, if a question appears where you have to talk about how maxima, minima are produced or change, what I want you to do is as follows. I want you to mention why light spreads, i.e. diffraction, little hint from me, because it's diffraction grating. If it's Young's double slit, it will spread because, well, it's diffracted each of the individual openings. Then what I want you to do is to mention superposition. And then what I want you to do is comment on the PDs, comment on path difference, comment on phase difference. And I've got a little template over here. So that little template on how to answer these is as follows. Okay, so in the chat, I want every single person, even if you're not doing AQA, because this will be just excellent, 5 minutes of revision, not 5 seconds, let's go at 5 minutes. Mention why light spreads, it diffracts, right? mention superposition, comment on the two PDs, not as in electricity, but comment on path difference, comment on phase difference. Okay, can you speak about constructive and destructive interference on this question? Yeah, I mean, you can, but it's the first maximum, right? So it's very, very specific. It's a specific type of constructive interference. Yeah, Collat's boson. Yeah, that's correct. If you say constructively interfere but without superpose, without make you lose marks. So if you're doing AQA, superposition is almost always underlined in the mark scheme. So I would use the word superposition because there's a slight difference between the word superposition, which means two waves interacting, and then the actual interference pattern that's produced when the waves are coherent and so on and so forth. Okay, Sarah, as the slot spacing is similar to the wavelength of the light will diffract as it passes through the slit. Okay, yeah, so just one little change just to ensure you get maximum marks, just change the slot spacing to slits separation, because that's the technical term for it, or you can call it spacing as well. That's all right, Ollie, welcome. Okay, light spreads because it goes through the diffraction grating and it diffracts. Yep, Nawal, that's absolutely correct, which produces superposition. So the individual waves from the individual slits will superpose. Maximum is where phase difference is 0. Okay, so I need you to comment now on the other PD, right? The path difference. So if it's the first set of maxima, then we know exactly which one is going to be. Okay, so right, let's do a couple of bits more of marking. So Ajita, light diffracts through the diffraction grating since the wavelength and the distance between the slits causes light to diffract and spread out. Yep, that will be 1 out of 3 or 4, whatever the question is. So far, so good. Izzy, light spreads due to diffraction. Okay, so slit size must be equal close to the wavelength for this to occur due to position of waves. 2, the waves interfere with one another. Okay, now, so Izzy, what you want to do is focus on the relevant detail because it says the first maxima, there's a condition, right? So the condition is, let me get rid of this. The condition is that, well, path difference is equal to n lambda for a maximum. Everyone in the chat, if we're talking about the first maxima, what is n going to be equal to, and what will the path difference be equal to? Every single person in the chat, let's flood the chat with good physics. I'm having way too much fun streaming. I should have done this ages ago. I've lost the chat. Okay, yeah, oh, that's fine. Yeah, perfect. Oh, Lewis, amazing to have you there. Thank you so much for the support. Okay, yep, fantastic. N is just equal to 1. So that, of course, means that the path difference is just equal to 1. And that's one thing that was missing out of a lot of the answers. We want, in order to get an A star, we want to be as specific as possible. We want to gain every single mark out there. Okay, so let me mark through a couple of more of your answers. So the light diffracts due to diffraction grating. Okay, so Z, light spreads through diffraction where the waves pass through a slit, and this will cause superposition where there's a 0 phase difference. It will cause a maxima. Okay, so you got the phase difference right. Technically, it's 360, but 0 will also be accepted. You really, really want to comment on the path difference as well. So remember, comment on the two PDs. So 1, mention wide light spreads. 2, mention superposition. 3, comment on the path difference. The path difference is exactly equal to the wavelength. Comment on the phase difference, and you're guaranteed some full marks over here and an A star, which is really, really good. Okay, so let me, why is my mouse scrolling the wrong way around? Would path difference be n lambda? Yeah, okay. Okay, so Fireverse, excellent name, that's cool. Light spreads through diffraction grating causing multiple source waves to code path difference and phase difference cause constructive interference in the first maxima. Yeah, so Fireverse, you want to give your specific path difference to be equal to the wavelength and the specific phase difference. You can also say that the waves are just equal in phase, essentially. Okay, so in terms of the specifics here, so it's a very good question because it's an explanation. You're right, it is implying it, but it's something that always appears on mark schemes. Unless the question says using ideas of path difference or phase difference, which I've seen more in OCR to be honest. Okay, so FA, the light is diffracted through the slits and the waves superpose constructively or destructively when the path difference is lambda, phase difference is 2 pi first maxima. Yep, FA, this will be 4 out of 4. Fantastic answer. Amazing. The waves of the first maximum meet at a path difference of 1 wavelength and are in phase, causing constructive interference to occur and bright spot forms. Okay, they are in phase. Yeah, so just the diffraction a little bit is missing. Okay, so this is super useful to see how you guys are tackling this. Here's my sort of explanation of it. So light is diffracted from the slits of the diffraction grating. It's called a diffraction grating after all. Hang on, I think I've got a diffraction grating. Yeah, just let me just show you this. There we go. Mine is about 300 lines per millimeter. So you should be able to see light diffract if I just put this on the screen. Oh, where's this gone? Gosh, I'm so new to streaming. Okay, so all right, you should be able to see me in various different colors because yeah, the light is kind of like spreading out. It's pretty cool. Okay, right, let's move on. Now let's do a different type of question. Whoa, I agree. So another type of question which appears for every single exam board. So it doesn't matter whether you're doing OCR A, B, doesn't matter whether you're doing Edexcel, etc. are Newton's laws of motion. Tell you what, first of all, how do you guys find Newton's laws of motion? Tell you what, rate Newton's laws of motion out of 10. Okay. I mean, they are probably the most useful, some of the most, I mean, technically, in order to derive a lot of these laws, Newton also invented calculus to try and work out the area between the moon and the earth. So he basically invented probably the most important bit of mathematics in history, which is a oh, that's funny, Lewis. Does anyone have any questions from for Lewis as well? We have Lewis from Physics Online in the chat. Any questions? We have some physics royalty. Brilliant. Oh, next 5 minutes. If anyone has any questions for Lewis, just ask away. Okay, now, right, so I know, yes, celebrities in the chat. What I wanted to mention is that here's a little diagram that describe and explain questions are a little bit like domino, right? So one thing causes another, and then causes another, and causes another, and causes another. And typically, what the examiners will do is that they're going to ask you something about like the fourth piece or the piece right at the end. And this is because they want to see whether you can link the cause and effect between one and the other. Now, let's have a go at this one here. So we've got somebody with a parachute is descending towards the Earth's atmosphere. explain with reference to Newton's laws of motion why displacing the atmospheric molecules causes a force on the parachute and why it causes the system to decelerate. So, right, tell you what, let me draw. Shall I draw a little picture over here? I do love drawing. Okay, let's see. Here's a little parachute. Here's a person. And we want to connect them with a parachute like this. There we go. Ta-da. So what I want you guys to do is to have a go in this in the chat, and then I'll show you a structure on how to tackle these exactly. So tell you what, first of all, have a go at these. Have a go at these with reference to Newton's laws, because the answer to this is almost always the same. For OCR 8, how should I tackle the 6 markers and intend to get 3 or 4 marks? So WIGMA, if you just stay for a little bit longer, we're going to do some 6 markers from OCR, probably either after this one or the one afterwards, and we'll be able to tackle them. Okay, Newton's third law, force exerted by parachute. So yes, you're going a little bit too far in the Domino's phase, right? Why am I thinking about pizza now? Never mind. This is not sponsored by Domino's. Maybe it should be. Now, what is it going to say? What you want to do is start off with Newton's second law. So it says, why displacing the atmospheric molecules causes a force on the parachute. So imagine that this is not drawn to scale, by the way, but this here is a water molecule. Oh, not water, it's not through water. This here is a air molecule. Now, if this air molecule were just relaxing, you know, enjoying life, enjoying the view from up there, and then suddenly this parachute moves over there and then gives it some momentum, what must be acting on this molecule? Okay, very, very interesting. So this question is causing a bit of trouble. I'm really glad I've put this into... So let me give you a structure, and this structure will be applicable. I've seen this in every single exam board out there. So, right, let me put this over here. Can I write this? I hope I can. Can I write this? Just one sec. Okay, so the first thing that I want you guys to do is to, okay, comment on the momentum of the atmospheric molecule. What's happening to it? Number 2, use Newton's second law. Then that means that there must be a force on the molecule, right? And then use Newton's third law. So tell you what, let's have you guys answer just the first 3 marks. Thank you very much, Lewis. Thanks for stopping by. Okay. Due to Archimedes' principle, it's a little bit more than Archimedes' principle, actually. Okay, as a parachutist defends the air molecules make more collision, this due to Newton's second law is due to change of momentum, tells us that change of momentum is increasing. Okay, so Seb, what you want to do is be really, really specific, because Newton's second law is this. F is equal to delta P over delta T. So everyone in the chat, what is happening to the momentum of the air molecules? What is happening to the momentum of the air molecules? It's increasing. That means that there needs to be a resultant force that's acting on them. Excellent. Really, really good. Teaching a class of geniuses. Awesome. Now, if there's a resultant force, ouch. If there's a resultant force that is acting on them, then that means that by Newton's third law, they'll be acting an equal and opposite force to the actual parachute. Okay, so let's word this one together. Let me see if I can. Okay, I swear I know about computers, sort of. Make this a bit bigger. Okay, that's a bit better. Okay, so comment on the momentum of the atmospheric molecules. So number one will be that the momentum of the atmospheric molecules is changing. Therefore, by Newton's second law, which, remember, Newton's second law states that the net force on an object is proportional to its rate of change of momentum, there must be a resultant force. Okay, that is Newton's second law. We've actually done this in one go. So we're going to use Newton's third law now. Let's see if we can word it. Newton's third law states that, well, please never write an exam, every action has an equal and opposite reaction. I don't even think that it's accepted these days at GCSE as well. So when two objects interact, they exert equal and opposite forces on one another. The marks are definitely going to go into identifying the pairs of forces. So the two pairs are as follows. One is the molecule. So the molecule experiences a force from the parachute, but then the parachute is experiencing a force back from the molecule. And there are two equal forces acting in opposite direction. They should be about equal. Let me make this one a bit smaller. Like so. Obviously, this is the combined force of all the molecules. It's not just one individual molecule. But Newton's third law says, well, there will be a force on the parachute from the air molecules by Newton's third law. Now, what about the final bit, though, is my final incredibly important tip. It's so important that I'm going to write this in the chat, but that's to see if you actually answer the question. Yeah, I mean, this is really what the drag force really is, because it's the combined force of all of these molecules kind of summed together. So, right. Now, did we actually answer the question? Angie, that is absolutely spot on. Experiencing resultant, yeah, perfect. We need to comment on the actual question, which is that in this case, well, what causes the system to decelerate? Can I make this a little bit bigger? I think I'll connect my iPad next time because I can probably just hand type it or handwrite it. Okay, there will be a force on the parachute from the air molecules. There will be a net upwards force on the parachute, which is opposite to the direction of motion, meaning that the parachute must decelerate. Fantastic. Could I explain the first point? Yeah, absolutely. So FA, the first point is as follows. We've got an air molecule. So tell you what, this here is my parachute. I know it's the tissue that I wiped the board with, but that's fine. This here is the air molecule, right? If the parachute displaces the air molecule, there needs to have been a force acting on it. Why is that? Because the air molecule just changed its momentum. And if it changes momentum, F is equal to delta P over delta T. In other words, if there's a rate of change of momentum, there needs to be a resultant force. How is that, FA? Is that all right? Yeah, so D, I would also say that there's a resultant force upwards, meaning that the acceleration is pointing opposite to the direction of motion. Okay, yeah, thank you very much for the tip, Ollie. Ahmed, why is there a net upwards force if we use Newton's third law to say that an equal and opposite force exists by the air molecules? So the combined effect of all of these particles must mean that there is a force which is bigger than the weight because it's decelerating. We know that it's decelerating because the question is telling us that it's actually decelerating. Hopefully that makes sense. Okay, very, very good. Now does this make sense? Because I've seen this type of question appear so many times. Now, right, we're gonna do one more question with a trick. But that little structure of linking motion with a force with Newton's third law and how something moves appears very, very often. So let's do a little question with a trick. Okay, so let me see, that's slide 16. Are you guys ready for a little question with a trick? The question is quite simple, but it had a very low success rate. Okay, have a go. If you're doing OCR8, you might recognize this question. Suppose the resultant force is not in the direction of motion. Yeah, absolutely correct, Johnny. How would you describe Newton's third law in another exam question to get the marks? So Karstag, when two objects, sorry, I'm losing my voice. When two objects interact, they exert equal and opposite forces on one another. So in the next question, we have two words, right? So we have state, we also have explain. Mia, it's an OCI question. I think it's quite old. I don't remember, to be honest, but oh, it might be an AS question. I think it's an AS question from OCR. Artemis, so the Newton's first law, an object will remain at rest or moving at constant velocity unless there's an external force acting on it. Second law, rate of change of momentum is proportional to the net/resultant force acting on an object. Newton's third law, two objects interact, they exert equal and opposite forces on one another. Yeah, it's very likely that, that you would have done this in year 12. Do you need to draw a free body diagram for this? No, so all you need to do, well, I mean, you can, but all you need to do is to state and then explain. So Ollie, you want to really carefully read the question. It says there's a little psychological phenomena, and I do this as well, by the way. So if you've noticed this problem, I notice this a lot when I'm tutoring, and also when I'm reading through questions and information. It's so natural for the human mind to kind of start reading and go, oh, I know this, and then not finish reading the question. So it says, state and explain the magnitude of the direction of the resultant force at X. And then loads of people are going to go like, oh, resultant force, the thing is not moving, it's got to be 0. But then the question says, due to the two forces exerted by the extended springs. So what does that tell me? It tells me, I feel bad about. Should I leave this drawing over here, or should I? Tell you what, it's gotta go. Sorry, even if it's a nice drawing. If I have like some point over here, and I have the weight acting downwards. I have some amount of tension here and some amount of tension here. I'm also given the value of the weight, right, which is 4.8 newtons. 4.8 newtons. So, right, it's asking me about the magnitude and direction of the resultant force due to the two forces. So basically, it's the resultant force of this one and this one, but not that one. And that is kind of sneaky. Okay. Yeah, so the way we should answer this is that the resultant force, or the force, I really don't like that they've called it resultant, to be honest. In fact, tell you what, I'm not going to even call it resultant, even though the question calls it resultant, but I'm going to say the force due to the two springs must be 4.8 newtons. Why is it exactly 4.8 newtons? Well, they have to balance. The horizontal components, what's going to happen to the horizontal components? Yep, 4.8 upwards. Fantastic. Well done, Mia. They're going to cancel out. Yeah, be gone horizontal components. We don't need the horizontal components. We only need the vertical 4.8, and then the system is in equilibrium. So this is kind of like, it's almost like if you have a lanyard, for instance, it works in exactly the same way. Oh, yeah, sorry about that. I don't know how to make my camera larger, to be honest, on here. Sorry about that. I can probably put this on here. Okay, so, right. Now, okay, who here is doing OCR? The question will be relevant to everyone in terms of the physics, by the way. Yeah, I will definitely upload my live stream afterwards as a video. Fantastic, excellent. Right, how do you guys find 6 markers? Yeah, sure. The answer for this is 4.8 upwards. Just one sec. Here, yeah. So resultant force is 4.8. Direction is upward / opposite to the weight. Okay, now 6 markers have a very definite strategy. So whenever you guys encounter 6 markers, I really want you to do 2 things. Actually, no, a few things. Number 1 is, let's make a little list of what to do, or what not to do, maybe. Can I do this? Wait, how do I text to this? Oh, there we go, my bad. Okay, how to tackle 6 markers. The physics of this question is totally relevant to other examples, by the way. I've got this, then I'll do one really cool Excel question. Maybe 2 even. Okay, how to tackle 6 markers. Number 1 is don't panic. I know it sounds really, really basic, but when I used to mark mocks and things like that, the number of missed 6 markers just from students skipping them is very high. So don't panic. Number 2 is see what you need to do. So all we need to do here is describe with the aid of a suitable diagram. Don't worry about the diagram over here. Maybe you want to describe it in the chat. How an experiment can be safely conducted to test the relationship between V and M. Now, so if you have to test a relationship, that means plot a graph. Of something against something. In this case, it's not going to be v over m, because that's not going to produce a straight line through the origin. But 1 over v squared against m, that's going to produce a straight line through the origin. I would say do your y is equal to mx plus c analysis before you tackle the question. Because then you'll know, and I always want you to write the following. So I would say write what you will vary and write what you will measure. So in this case, for instance, you could vary the mass m and see the output that it has on the speed v, and then you would plot 1 against v squared for m. Very often, though, if there's a lot of variables, something will need to be constant. So in this case, d might need to be constant. Q and R, I think, are just constants in this case, but something will need to be constant. If there's the word sort of safety in there, make sure to write a safety comment. For instance, make sure that you're really careful for this not to drop on your feet. Make sure that you're wearing safety goggles, for instance, if we're talking about a wire that might have the potential to snap, etc. Okay, for safety, I would avoid general statements which should be done, things like kind of putting your bags under the table and things like that. So these are a little bit too general. So we want detail. And after you do this, you will have a really, really high mark. So measurements with instruments. So every single measurement needs to have an instrument. If you go through this checklist, I don't see how you're not going to score like 5. So, right, what I want you guys to do is see if you can formulate an answer to the 6 marker. I think there might be a chat limit to how much YouTube allows you to send as a message, but if you need to send a couple of messages, that's fine. Yeah, so this is an OCR question. It's more relevant towards AQA paper 3, to be honest. But let's see if you can formulate the question. Feel free to abbreviate quite a bit, and I will do my best to provide you with, I would really like to mark your entire work. Yeah, we're going to measure D with a ruler because it's a large distance, so we don't have to use a micrometer. If we do have to measure something with a micrometer, we will need to take multiple readings, then find the mean. If you're finding this very, very useful, by the way, next week on Tuesday for Edexcel, Wednesday for AQA, and then Thursday for OCR, right before paper 1. I'm doing these live revision sessions on Zoom. They're over 4 hours long, over 5 hours long. So if you need any extra help, do sign up for this. I think I've left the link in the top part of the description on here. Okay, so yeah, I agree, Johnny. So it's a lot of it is about they try and scare you away with a messy equation, but in reality, if you just stick to the principles, it's going to be totally fine. Okay, yeah, very good. So Joseph, yeah, measure the speed using light gates. Okay, graph of 1 over v squared, keep d constant. Light gates connected to a data logger to measure v. Okay, plot a graph of 1 over v squared against m. Expect a non-zero intercept with a straight line. So, one thing that I would change for your answer is the actual wording. So if you're doing OCR, I'm just going to write in the chat because this is important as it gets, and I'm sure I'll see a lot of this. So the statement after you've plotted your graph that I see lacking is, if the relationship is correct, the graph will be a straight line through the origin. And this is something that always appears in math schemes, you know, especially if you're doing RCRA, NB as well on some 6 markers, this appears a lot. So uncertainty for the absolute uncertainty, or should we just talk about resolution? The resolution of a standard ruler, the smallest thing is the smallest thing you can measure. So for a ruler, that's about 1 millimeter, right? That's the resolution. For a micrometer, it's a much higher resolution. So it's one way of improving your uncertainty. What would cause a line not to go for the origin, Danny? The answer is a systematic error. Oh, sorry. Yeah, sorry for this statement. Can I just change it? I'm just going to remove the previous statement because in this case it doesn't go for the origin. So if the relationship is correct, the graph will be a straight line with an intercept r in this case. If r was 0, something like, I don't know, Hubble's law, for instance, or v is equal to IR, then you will see this appear a lot. Okay, I find non-experiment 6 marker the hardest because I don't have a set formula of how to ask them, especially if I cannot break it down into small questions. Yeah, Angie, I agree. So the good news is that everyone finds these questions tricky. Every time you look at 6 markers which are non-experiment based, you need to focus on the physics. They tend to kind of not repeat themselves very much. So they happen a lot in astrophysics, for instance, where they might give you a luminosity question. I think I've got a playlist somewhere. They happen a lot in nuclear physics as well. But I would just focus on the physics content, and then asking exactly what the question is, answering exactly what the question is asking. It could be a perfect just calculation. So some of them try to scare you away, but in fact, they're just a calculation. This is also, yeah, plot graph of 1 against v squared against n, the grain should be equal to k. Okay, so let's have a look at this. So this mark scheme over here, and we'll just analyze it a little bit. So this is how OCR marks these. So because they asked you, obviously this is kind of an online lesson, we've got a label diagram including light gate's position at P. So you want to place actual light gate over here. Somebody asked before, light gates tend to measure the time spent between them, and then you can calculate the velocity by putting an interrupt card on the trolley. So you wanted to put an interrupt card here and a light gate at P. Okay, card added to a trolley to interrupt the light beam. Description to the procedure. Repeat experiment for each m. The description would be vary the mass, for instance, measure the speed, v, keep d constant. And then this is something that is lost all the time. Method of keeping d constant. For instance, you can mark the starting position. Okay, method to stop the trolley hitting the pulley, for instance, a sandbag / a cushion, using a release mechanism, etc. Measurements. You use a ruler to measure the length of the cart. Use a balance to determine m, method to determine w. So method to determine w is just the weight of these, isn't it? So you can use a Newton meter, for instance, if it's a force. If they're relatively small within the range, you can use a top and balance as well. And then analysis. V is equal to the length of the card over time, plot a graph of 1 over v squared, and then the gradient is equal to this kind of horrible expression, 1 over 2dw minus q, r is equal to y minus the y is equal to the r is equal to the y-intercept. And finally, it's rearranging for the gradient. Would the trolley itself not interrupt the light beam? Typically not. So in practice, when I've said this in labs, you need an interrupt card. Is there a foolproof way to determine what is plotted on the x and y axis when given a new equation like this? So very often there's different formulas that require different things. What I would say is do lots of these and always think what will produce a straight line through the origin. So in this case, what we had was 1 over v squared. If I plotted v against m, it will produce some sort of curve which would be really hard to analyze. But if I was to plot 1 over v squared against m, I know that I'm going to be getting y is equal to mx plus c. Why does it have to be a light gate? Can you not say stopwatch? So because we want to measure the instantaneous speed, so this is why. And in general, the instrument that we measure speed is a light gate. It's the most reliable way of doing this. If there are square relationships, does it matter whether you plot a graph using square terms on the axis or use logarithms? I'll have to look at a particular example, but if it's mathematically correct, it shouldn't matter. Does the surface not being smooth not have an effect when using light gates? Does the surface not being smooth? Does the question actually talk a little bit talk about the surface here? Let me see. On a horizontal surface. So rough surface would just mean that there's friction that's actually present. So no, my answer is no, it will not affect the use of light gates. Light gates measure time typically, although some newer models, to be honest, I think the mass schemes are a little bit stuck in the past, but most modern light gates will just give you the speed directly. But I would say in questions, assume that they measure time. Okay, unrelated question, but I finished all the new and old spec questions from my exam board. Do you say do Isaac physics on weak topics? I would say, oh, you've done, oh, first of all, you're in a fantastic position. I would see if you can get 100% on them. Pick a random one, because this will be a massive confidence booster. Like if you get like 95% or between 95 and 100%, you know that you're doing really, really well. Hi, Yasha. Okay, right. Shall we do a kind of a hard electricity question? It's from Edexcel, but applicable to all exam boards. If you're doing OCR, it'd be more applicable for paper 2, but if you're doing AQA and if you're doing Edexcel, this is very, very applicable. No. Okay, right. Okay, so let me see if I can find it. Just 1 second. So I really, really like this question because it shows you how transformers actually work. And this is one of my final tips for today. It'll be the final question we do today. I'm really enjoying this live stream. I might do a couple more of these this week, by the way. Do you guys want me to do another one of these? Or do you prefer me just posting a load of videos this week, which I'll probably also do? Where's the chat? Okay, very good. Excellent. Okay, so what do we have? If you're doing Edexcel, do you recognize this question? If you're doing Edexcel, by the way, my full-on last-minute paper 1 revision session just on Edexcel stuff is, gosh, what day is it today? It's on Tuesday. So yeah, you can sign up for that with the link in the description. What is my favorite circuit symbol? Very good question. What is my favorite circuit? I never thought about this. I really like LEDs. I don't know why, but they're cool. Nobody is cooked, guys. You're all cooking, remember. Okay, now, so it says explain the operation of the circuit, but it also tells you what to include. So I want everyone to have a go at this question. It's a really good explanation question. See if you can have a go at this. Have a go. Did you see this question on Reddit? That's amazing. It's all right. We can figure it out. If you're doing OCR, it's a paper 2 question, I'm afraid. If you're doing AQA or Edexcel, yeah. Question looks shocking. Well, the LEDs don't take that high of a current to actually shock you, so. No predictions, I'm sorry. I can't predict. Nobody can, and I'm not going to pretend that I can predict stuff. Okay, now let's what am I even looking at? Okay, so let's make this really simple. I'll try. Can I actually draw on this? Let's see. Can I draw on this? Okay, so you guys are gonna have to follow my mouse cursor. Okay, so let's consider that if you're doing Edexcel. Okay, tell you what, a little bit of a backstory, but an LED will only let Optimus Prime looking circuit. That's amazing. Chat. So, I mean, technically it does transform voltage. So now let's just focus on the circuit. If the voltage is positive, that means that current will go from this direction back into the other one. So let's see if you can follow my mouse cursor. Okay, right, chat. So the current goes through here. Hopefully you can see my mouse. Current goes through here, current goes through here, current goes through here, current goes through here, current goes through here. Oh, wait, are we gonna go through D1 or D2? D1 or D2? Everyone in the chat, D1 or D2? D1 or D2? Yeah, perfect. It's gonna go through D2 because current always, well, it has to go from positive to negative. So it's gonna go through this one. Okay, D2. Then, can it go through D3? Go ahead, chat. Can this go through D3? Yes or no? Nope, it absolutely cannot go through D3. So it's going to go through X, and then it's going to go through R for this direction. So one part of this, tell you what, let me just write this in the chat. I'm going to join the chat as well. Why not? So the current, when doing positive half cycles of voltage, the current flows through D2 R, and afterwards, what is it going to flow through? It's going to go through D4 and then back into it. And D4. So how does that work? So after it goes through here, it's going to go through here, through D4, like that, and then back into this one. Okay. Now, so we're kind of halfway there. We've made reference to D2 and D4. So probably when the current is negative in the other way, it's going to flow through D1 and D3. And these are some of it. So why can't it go through D1 back around again? Because it will just be in the opposite direction. So it only goes from positive to negative. Yeah, so that's a very good question. So that is a very, very good question. How do we know which direction is positive? So I've just always assumed that this one here will be positive and this one here will be negative, but actually it doesn't really matter, because if we're to have this symmetrically, the answer will be absolutely identical. Now, on the other side, so let's do it. Let's kind of consider the other cycle. So if the voltage is going from here, if the current is going from here to there, Okay, so which way is it going to go? Well, it's going to go through here. This is just two lines meeting. It's not a junction. There's no dot. So it's going to go through here. Okay, it's going to go through D3. Okay, goes through D3. Okay, then, but look at this. It once again, it is an Optimus Prime circuit because it goes through X in the same direction. It goes through like this, goes through Y, like that. And then, remember, this is not a junction, so we're still going through. Finally, we go through D1 again, and then we're back into here. And in both of those cases, the voltage across R is always in the same direction. The current is always in the same direction. So the PD goes through. Excellent to hear, Johnny. Goes through. What does it go through? Gosh, I forgot. It went through. Where's my question? Yeah, it goes through D3 and D1. And the PD across R is in the same direction. This is from Edexcel, this particular question. So I've covered like all of the major exam boards. Okay, awesome. Yeah, so yes, yeah, it generally just switches the alternating current to direct current. So it's a really clever circuit. Yeah, exactly, yeah. At the resistor junction, wouldn't the current split at the resistor junction? So at the moment, there's nothing else connected across the other two terminals, as far as we can see. But I've just imagined a voltmeter plugged in there with infinite resistance. So the answer to this, which I have on this next slide, is the following. I think it says something similar. So let me just make this a bit bigger. That only lets current through in one direction. Okay. In positive half cycles, D2 and D4 conduct. And then in negative cycles, or the other way around, D3 and D1 conduct. Current towards X through R is always in the same direction. But look at this. In the case of this one, we've always made sure that we've answered the question just really, really accurately. What's a half cycle? Basically half of that. Basically means when it's like this, when it's like that. Because half of it is positive, half of it is negative for AC current. Okay, now 2-watt. So I'm going to spend a few minutes just answering any general questions, not necessarily on the physics, but anything on how to revise or things like that. And then I shall have some lunch. So let's change this to questions. Any questions that I can help you with? Okay, questions. So why doesn't it go to the negative terminal? The positive and negative basically swap when you have an AC supply. What is the best way to revise for 6 markers specifically? Do lots of them, and do them in an analytical way. So aim to improve every single time, because if you just do all of them but don't try and improve, then you probably won't. But if you do 3, 4 of them of different styles, that will really, really help. How can I go from A to A star in a few days? Don't know how to fine tune my exam technique. Depends, because I don't know your exam technique, so I don't know what are your strong and weak points. I would focus on trying to see if you can spot what your weak points are. It could be timing, for instance. If it's timing, that's something that you could potentially very easily fix just by doing them in a timed past paper, and then being really honest with yourself and going, okay, did I spend too much on this question? Can I, for instance, rearrange first and then plug in numbers right at the end? Because if I plug in numbers right at the end, I'm only using my calculator once versus using it 4 different times. So that's a way to improve. What to do before the day before the exam? I would try and finish the vast majority of your revision beforehand. Open up a folder with all the questions that you've gone wrong, any single question you've gone difficult, glance over it, If there's anything else, just drop a comment on one of my videos and I'll do my best to respond. I'll do my best to respond to as many comments as possible in the last and the day before the exam. What are the conditions for Newton's third law? So you need two objects to actually be interacting. They could be interacting at a major distance. AK, don't quit. You totally got this. Any suggestions to tackling comprehension for component 1 educas? When is component 1 educas? So the component 1 on educas has a lot of sort of specificity, like things like materials, for instance. Wait, you're not talking about the AS one. So I'm not super familiar with the second year exams, but I would look at any derivations that might be present, and some parts of it are very, very specific. For instance, materials and a few others have a few things which are very, very specific in the mass games. So yeah, I would recommend looking over those, going for the past papers. For EDUCAS, I would also recommend doing the WJC papers, which are really, really similar, but they give you a lot of extra practice. Okay, which topics usually interlink in papers? I can't really answer that, to be honest, because examiners are just really, really, really imaginative. I don't get gravitational potential. Why is it minus? Okay, so Road, let's answer this. Road, are you still in the chat? Road. I'm going to try and answer a lot of those questions. Yeah, perfect. So why is the gravitational potential negative? So it's such a good question. Here's the Earth. And then I'm just going to stop sharing my screen just for a moment, just so you can see this a little bit better, my actual board. Okay, so you can hopefully see me a little bit bigger now. Here's the Earth. Shall we draw it properly, not just label it? Okay, let's draw it properly. If I ever taught you in person, you probably know that I love drawing. It's the UK. This is like Europe. It's like the North Pole, Africa, Asia. There we go. Not too bad. Okay, so here's the Earth. The question is, why is the gravitational potential negative? If I'm at a point here, actually, to answer why is it negative, we have to talk about what it takes to escape. So if we consider the total energy of a satellite, like this, what is the condition for the total energy of a satellite to escape? I would love to have a degree now, but I don't. So the condition for the total energy is, we've defined that to be 0. One way of answering your question is the following. So total energy, if total energy is 0, then that means that the GPE plus your kinetic energy has to sum up to 0. So kinetic energy is always positive. It's just a half mv squared, right? So one way of answering your question is to directly say that the gravitational potential energy, and hence by extension the gravitational potential, has to be equal to 0. Sorry, it has to be negative. My bad. It has to be negative. Sorry, I've been talking for a very long time. My brain is a mush, but it's fine. It needs to be negative. So that's one way of answering this. Another way. Who asked this question? Let me just check. So are you doing maths? Are you doing A-level maths as well? Because to really answer this question, I need to integrate. Yeah, Road, are you doing A-level maths as well? E total. Yeah, I mean, maths is pretty awesome, but don't worry, like you can score 100% full marks even without A-level maths. Oh yeah, sorry about that. I think I can probably change this, but okay, let me just show you. So for those of you who do A-level maths, let's just so it's 0 by definition. Basically, it just makes. Okay, so let me explain it. It's super cool. So the gravitational force is defined as G. The magnitude of the gravitational force is defined as gmm over r squared. In general, in physics, work done is equal to the integral of force with respect to distance. Force times distance is only true for forces which don't vary with distance. This here, my friends, is a definite integral, which means we need two boundaries. I'm going to say from R1 to R2 because I'm interested in figuring out how much work it takes to take something from R1 to R2, for instance. So, okay, well, this here will then be equal to the integral of gmm is just a constant. The integral of 1 over r squared is, what is that? 1 over r to the power minus 2 plus 1 divided by that is going to be 1 minus r, right? That's where the negative sign comes from. Plus, no, sorry, minus r1 minus, which is a plus. No, hang on, r2, r1, like that. I think that's right. I'm a little bit tired, so my integration brain is not on. Now, what is the definition of the gravitational potential? If you remember, put that in the chat. Definition of the gravitational potential. Hopefully you remember. It's the work done taken per unit charge, taken objects from where to where. If you like Star Trek, you will know what I'm about to say. From infinity to a point and beyond. Okay, now 1 over infinity, if there are few mathematicians here, sorry, but 1 over infinity tends to 0. It's not 0, but it tends to 0. So we can get rid of this. The reason why we choose infinity is because we make this calculation so much easier. If we didn't choose that with respect to infinity, we would have different people disagreeing on the amount of energy required to go from somewhere to somewhere. And also it would be a lot more difficult for your A-level exams to actually consider this as the expression for gravitational potential energy. So long story short, this is where the minus sign comes from, because the integral of 1 over r squared is negative. Okay, so this gives you ESAT vibes. I do love the ESAT questions. Okay, never mind. Right, okay. I can always find a way to plug in integration because I love that. Any general tips for mechanics? I always struggle figuring out what equations to use. I think drawing things on your diagram and then visualizing them on your diagram is really, really helpful. Okay, let me answer a few more questions, then we'll have to call it a day, I'm afraid. In what case does Newton's third law not apply? Okay, so yeah, so there's a question which is very often appears in all exam boards to try and confuse you, and that is normal reaction. So here's one. And then if you have the weight of this object, I don't know, it's 100 newtons. Then the ground, oh, it's such a clever, it's almost like a computer thing, because there's like this elastic compression that gives exactly 100 newtons back upwards. The mathematics behind normal reaction is absolutely fascinating. I need to do a video about this. But yeah, this here is 100 newtons as well. So, right, what are we talking about? These two forces are not Newtonian pair. So the reason why they're not a Newtonian pair is because, number one, they act on the same object. And Newton's third law says that when two objects interact, they exert equal and opposite forces on one another. So, right, that is, I don't know, here's object A, here's object B, and then this one here experiences a force from B, this one here experiences a force from A. So we have two separate forces acting on two separate objects, whereas here we've got two separate forces acting on the same object. Additionally, there are different types of forces. Well done, Zola. So this one here, the normal force, is actually deeply an electrostatic force caused by the repulsion of electrons in something known in quantum mechanics as the Pauli exclusion principle. Fascinating stuff. But yeah, it's an electrostatic force, loosely. Whereas the weight is deeply a gravitational force from the gravitational interaction. Are you doing a live stream? Probably, yeah, why not? Pauli mentioned, of course. What is third law pair for the normal reaction force? So what is the third law pair for the normal reaction force? Okay, so it's going to be because that's such a good question. Now, it's deeply caused by those having charges, right? Because let's say that my calculator here has electrons on its outer surface. If I was to put them here, they interact with the top surface charges of the molecule. So those two are are the actual Newtonian pair. The Newtonian pair for the weight, though, is the Earth itself, because this thing is exerting a force on the Earth back upwards as well. So if this here is the Earth, you can imagine that the Earth is experiencing the same sort of vector, but a smaller one. Okay, do you force on a block on ground gravitational force? Okay, do you get all the marks for non-troll questions if you're working different from the mark scheme? If you're using correct physics, yes. Very occasionally, you might get the correct answer with wrong physics, typically because of things like small angle approximations or something like that. Do you recommend trying to predict questions will come out? No, not at all, Zeno. So in fact, if you're doing OCR, has anyone done the 2023 OCR papers? So I remember in 2023, gosh, feels like a long time ago, but 2023, if you look for the papers, there was like no electromagnetism on paper 2. And paper 2, usually there's quite a lot of electromagnetism. So everyone thought, okay, there's going to be a ton of electromagnetism for paper 3. And no electromagnetism came up on paper 3. It's just, don't try and predict it. Be really confident you got this. What are the key points to memorize for electricity? I recommend not memorizing stuff for electricity because it's all problem-solving based, except for a couple of things like IV characteristics. So I'll say go over the IV characteristics. I've got a video on all of electricity I posted recently. Have a go at this. Should we do multiple choice questions first or last, Matthew? I would say practice past papers and see what works for you. When I do the papers for fun, I would just go over the entire paper in that particular order, but there's no particular reason for it. The only thing I would say is if you're doing multiple choice questions last, do not skip questions. I see this a lot. Why do things rebound after an elastic collision? Because kinetic energy is conserved, so they need to have the same speed after the reflection. Absorption and emission spectra. I do have a video on that. If you just literally type in absorption and emission spectra, you're going to see this. Okay, do we need to know about primordial helium and the Big Bang Theory? Can you explain it, please? I think primordial helium is just used as evidence for the Big Bang Theory, and occasionally it's appeared on a couple of mark schemes for OCRA, but I would probably kind of recognize that it could be one of it, but I don't think it's on the specification. I will have to just double check that that's the case. Please double check though. Don't take my word from it. You definitely want to know about Hubble's law, and you definitely want to know about the cosmic microwave background radiation. Can you go over drawing momentum diagrams for particle? Do you mean Feynman diagrams, Gerika? They have the same magnitude. How many significant figures do you give answers to? Would it be penalized if you give too much? So depending on your exam board, I give my significant figures to the lowest number of significant figures in the question. So in OCR and AQ, I think you penalize just once. And then if you do more significant figure errors, unless it's a practical question. Is Newtonian pair a thing we talk about in AQA? Yeah, a Newtonian pair is basically Newton's third law. That particular question has definitely appeared in AQA. Wait, force need to be a Newtonian pair, so force acting which quiz, but no result. Wait, that. So Newtonian pair is basically a consequence of Newton's third law. Okay, can you make a video for all possible derivations? I think Lewis has a lot of these, to be honest. So I've got most of the derivations part of my kind of summary topics. But yeah, unfortunately, guys, I do need to run. I promise I'm going to do this again. I've had so much fun. I was really nervous before this live stream, but I've really, really enjoyed it. Thank you so much for coming. If you would like to join my last minute sessions, secure yourself a spot using the link in the description. Thank you so much. I really, really appreciate it. I'll plan it and I'll let you know when the next stream is, but I need to have a look at my calendar. But yeah, thank you so much, guys. Thank you. Thank you so much. Thank you. Enjoy the rest of your day. Absolutely smash it. Absolute stars. Thank you so much. Thank you.